And here we look at the isomorphism between the Boolean algebras. For two Boolean algebras, B1 and B2, to be isomorphic, there needs to be a bijection, so some function f that takes B1 over to B2. And it must preserve the Boolean operations. That means for all x and y in B1, we're going to have f of x plus y equals f of x plus f of y. F of x times y is equal to f of x times f of y. And f of x complement equals the complement of f of x. Or you can write that, remember I'm using that prime here, but you can use the bar on top as well. Okay, so I do have to preserve those Boolean operations of addition, multiplication, and the complementation over to B2. So the bijection f is called an isomorphism between B1 and B2. So let's look at this example. Let B be the Boolean algebra of the set 0, 1, and let P of S be the Boolean algebra of subsets of S, where S is just the set A, so it just has one element. So if you look at the power set of just a singleton, what does that mean? Let's prove that B and P of S are isomorphic. So P of S, this means, is just the empty set and the set S. So this has exactly two elements, and so does B, which is 0 and 1. So what is the bijection? The only bijection that is going to be an isomorphism of the Boolean algebra will have to be this definition of f. F is going to start at B, the 0 and 1s, and map you over to P of S, where we define f of 0 to be the empty set and f of 1 to equal the set S. So remember our inputs here, we need to have that come from B. So that's why you have 0 and 1 that you're plugging into your function f, and the output needs to be the second Boolean algebra, which is P, and what's in P, the empty set and S. So this is the combination that does work. So how do you verify it? To check this, we just check that those three properties are going to hold, and we can use a table. So here are three properties that we need to make sure are satisfied for this Boolean algebra. The three operations have to hold, and let's see if it works for our f. So for our bijection, does this work? I'm going to start with property 3. Does property 3 hold? So again, I'm looking at inputs of x to be 0 or 1 because they're coming from the Boolean algebra of the set 0 and 1. And I'm just going to see if f of x complement equals the complement of f of x. So notice if you do f of 0, you get back the empty set. F of 1 is the set S. Then I do x complement, get that column, and then do f of x complement, so remember to use this as your function output values. And then I take the complement of f of x, so I have to make sure to go to this column and then take its complement. So the complement of the empty set is S, the complement of S is the empty set, and if you now compare these last two columns, they are the same for each of those x values. So property 3 does hold. Now let's check 1 and 2. So for 1 and 2 to hold, you're looking at x's and y's. So that means x and y, they're both coming from B, and they have the choice of 0 or 1. So that's 2 to the second, which means 4 different pairs. So I have this one, this one, this one, or this one. And you just go ahead and do your f of x, your f of y. Remember what your f is. I wrote it up here to remind you this is what we're saying is defined as our f, this part right there. And after everything's done, you can see the last two, well, the second to last, is going to hold for property 1, and then the last two columns hold for property 2. So if 1, 2, and 3 hold, you are going to have your bijection f to be an isomorphism between B1 and B2.